Good evening. Here is another PPT. Uh, Bridges, types of bridges, components of bridges, design concept for bridges, and its failure. In this PPT, we are going in depth analysis and technical overview. So first, classification of bridges, which is based on function. First, road bridges, designed for vehicular traffic, including light and heavy vehicles. Next, railway bridges cater to train loads and require special design for dynamic forces. Pedestrian bridges meant for foot traffic, design prioritize light loads and aesthetics. Pipeline and utility bridges carry services like water, gas, and electricity. Next, cla- classification is based on material. Timber bridge, uh, traditional used in rural or temporary applications. Steel bridges, high strength, good for long spans but prone to corrosion. Reinforced concrete bridge, durable and versatile, widely used. Pre-stressed concrete bridges used for longer spans and reduced structural depth. Next classification is based on structural form. Beam or girder bridges, simple structure, common in short span. Arch bridges, transfer loads through compression to abutments. Truss bridges, composed of interconnected triangles, ideal for heavy loads. Suspension and cable stayed bridge, used for very long span with slender profiles. Next, components of bridge. First, then there is superstructure. Deck, a surface on which traffic moves. Girder or beams, primary load carrying members. Next, slab, transfers vehicle loads to girder and cross girder and bracings. Provide lateral stability. Next component of bridge is substructures. First, uh, piers, vertical supports transferring load to the foundation. Next, abutment, end supports that retain approach embankments. Wing walls, uh, retains earth at bridge approaches. Pedestal and bearings allow movement and distribute loads. The next topic is bridge foundations. First, shallow foundation, spread and pad footing used where soil is strong. Deep foundation, piles and well foundation used for poor soil conditions. Score protection, stones, mats, or concrete to prevent erosion near foundations. Economical span concept. Economical span, which is minimum total cost. Here, superstructure plus substructure. Next, shorter span needs more piers. High, higher substructure cost. Longer span needs stronger girders. Higher superstructure cost. And next, optimizing need for material and labor efficiency. Afflux, rise in water stream level due to bridge obstructions. Importance in flood prone areas to avoid upstream flooding, calculated using formulas like Molesworth or empirical charts, requires provision of adequate waterway area. Next is HFL, which means high flood level. Highest level attained by river during maximum flood. This is known as high flood level. Used to set deck and foundation level. Freeboard is added to high flood level HFL for safety, determined using hydrological and historical data. Score depth. Depth to which riverbed may erode around bridge foundation depends on flow velocity, soil type, and obstructions. Calculated using LACIS or IRC formulas, crucial for safe foundation or depth design. Loads on bridge. Static. Dead load. Self weight of all bridge components. Live load. Vehicular or pedestrian traffic. Static earth pressure from backfill against abutment. Settlement loads due to differential foundation settlements. Loads on bridges and loads on bridges, which is dynamic and environmental. Impact load, effect on moving vehicles. Wind load, pressure from high winds, especially on tall bridges. Seismic load, earthquake include induced forces. Temperature load, expansion on contraction due to thermal effects. IRC loads specification. IRC class A, normal traffic on all roads. IRC class AA, heavy industrial or defense vehicles. IRC 70R, military tanks or equivalent. IRC class B, load traffic and rural roads. Obs- uh, Obsolete, but many exist. Load combination also specified for design safety. Bridge failure in India overview. Frequent causes: score, overloading, or and poor maintenance. Construction defects or use of substandard material. Hydrological misjudgments. Example: ignoring high flood level HFL or efflux. Inadequate specification and retrofitting practices. Bridge failure examples are in India. Morbi Bridge 2022. Pedestrian bridge collapse due to faulty maintenance. Kundali Manesar Palwal Bridge Expressway KMP Expressway collapse during construction. Several railway bridges failure due to score and aging. Highlights the need of for periodic safety audits. Maintenance and inspection. Routine, periodic and special inspection, monitoring score, cracks, corrosion and bearing movement, use of technology, drones, sensors, non-destructive testing entity, timely repairs, extend life and avoid costly failures. Conclusion for this PPT. Bridges require multidisciplinary expertise for safe design and longevity. Load consideration, hydrological and foundation depth are key. Failures often due to avoidable human and technical errors. Sustainable infrastructure demands better planning and regular inspection. Thank, thank you.